Oh, it is 4:21 on a Sunday. That means it's time for some more econometrics. Hmm, not much flavor, not much flavor. All right, you get to my computer. So today's lecture is going to be relatively quick one. Today's topic is irrelevant variables. Irrelevant variables are a complement to omitted variables. I'm going to go ahead and share my screen. Yes, that's the one. Irrelevant variables are a topic really, to understand irrelevant variables or why we talk about them, it's a question of when should a variable not be in my regression? When do I have too many variables? When should I kind of conclude that a variable that maybe I thought was important actually is doing more harm to the model than helping it? And I see it as a complement to omitted variable bias because irrelevant variables, like omitted variables bias, are a violation of assumption one, that the model is correct. Omitted variables bias is kind of a set of criteria for us to understand when are there variables that aren't in the model that should be, whereas irrelevant variables are the other side of the coin. When do I have variables in my model that shouldn't be? So the definition of an irrelevant variable is really just that, an erroneous independent variable, a independent variable that is included in the model but shouldn't be. Why do we care about irrelevant variables? What's kind of the harm? Why don't we just always include every possible variable you can in a model? So the answer to that is that when you have irrelevant variables in your model, they decrease your degrees of freedom, which is another way of saying they decrease the precision or the estimation power of your model. So if you have too many irrelevant variables in your model, the standard errors for your other variables, for your other slope estimates, might be bigger than they otherwise should be. You might sort of harm yourself on your quest to find statistically significant results with other slope variables if you include too many irrelevant variables. And when it comes to irrelevant variables, we have kind of a four-step method for detecting them. And I'm just going to go through them right now, and then we're going to see an example in Stata, but this is going to be a pretty quick lecture. So the first thing you should ask yourself when it comes to an irrelevant variable is, does theory justify that variable being included? Theory trumps everything. If the theory says, no, this variable really should have a direct impact on the outcome variable, go ahead and leave it in, even if after you run a regression you realize it's not statistically significant. Theory trumps everything. If you have a variable in your model that theoretically is maybe on uneasy ground, you have reasons to think that maybe it's kind of a redundant variable or that other variables in the model capture certain effects better, then we go to steps 2 through 4. To ascertain whether or not a variable is irrelevant, first, you look at whether or not it's statistically significant. You use the t-test. A variable that's statistically significant likely is not going to be an irrelevant variable. After the t-test, then you can consider the adjusted r squared of the irrelevant variable. Does the adjusted r squared go up, go down, stay the same when I include or exclude the variable in question from the model? And then your last criteria is bias. If you take an irrelevant variable, if you take a variable out of your model, if it causes bias in the other variables, that is to say, if you take a variable out of your regression, if the values of the other slopes of the other coefficients in your regressions change dramatically, then that's an indication that the variable you just removed, by removing it, you're introducing omitted variables bias into your model. And so omitted variables bias, by and large, is worse than having an irrelevant variable. We'd err on the side of having an irrelevant variable rather than causing omitted variables bias. And so if theory doesn't justify leaving the variable in, then the next three things you ask yourself, and steps 2 through 4 here really can be asked sort of in any order. These three are all taken together. Is the variable significant? What happens to the adjusted r squared? And does it cause bias? So, and we're going to do a practice of those 4 steps in Stata in just a second. How do you correct If you find that you have an irrelevant variable, how do you correct for that? First of all, you could do nothing. If you determine that the problem's not that bad, or that it's kind of you're on the fence about whether or not it's an irrelevant variable, do nothing. That's fine. One of the few cases in econometrics where just doing nothing is a perfectly acceptable answer. The second option is to remove the irrelevant variable in question, rerun your regression without it, and use those results. In the other column here, I'll just remind you that not every statistically insignificant variable is automatically irrelevant. So you should only be removing variables or declaring them irrelevant if theory sort of justifies that they may not be relevant in the first place. All right, and so now I'm going to switch over to Stata. We're going to walk through two quick examples of irrelevant variables, and then we will be done with this lecture. So let me pull up Stata. There we go. I learned from the first couple of videos that the screen sharing takes a second, so I know when I have something on my screen, it's 4 or 5 seconds until you have it on yours. And so there's going to be a little bit of a pause each time I kind of switch screens here. All right, so this is our wages data set, the one that from the Hammermesh paper that you're going to use in the beauty lab later on the semester, but ultimately it's a good place for us to consider the impacts of an irrelevant variable. So the now let me skip that. So let's consider some of the variables we have here. Our outcome variable is going to be wage. And we have some of our normal heavy hitters for things that predict wage, your education, your experience. In this case, we also have data on whether or not you're married. And the variable I'm going to kind of use here as a potential irrelevant variable is your age. So why might age be an irrelevant variable in this case? Well, first of all, let's look at a regression between wages and age. Regress wage and age. And see what we get. Oh my goodness, we get a highly statistically significant result. So we might say to ourselves, no, of course age isn't an irrelevant variable. But ask yourself, given the other variables that we have here, why might age actually be non-essential in this model if we kind of run the correct model given these sets of variables that we have? All right, well, after that probably unnecessary pause, you could have just paused the video after all. If we think about a project map, if we think about what sort of things directly impact a person's wage, one answer to that should be kind of how good of a worker they are, the quality of work. And if you were to ask yourself, how might I measure quality of work or how strong of an employee someone is, you might say that you would measure it based on age, but you also might say, and probably the better answer is that you might measure it based on their work experience. People with more experience have learned on the job, they've learned how to do things more efficiently, and so experience might be a pretty good proxy for how valuable or how good someone is at a certain type of job. It turns out that experience and age are very highly correlated. So just like age has a positive correlation with wage in a model, if I just looked at regress wage on experience, we'd also expect, and sure enough, we find a positive and statistically significant correlation. If we run a model looking at the impacts of wage on wage of, let's say, education, whether or not someone lives in a big city, sorry, education is just EUDC, experience and age. So if we run this regression and we're going to ask ourselves now, is age a relevant or an irrelevant variable? So after we've run this regression, the coefficient on age comes up as statistically insignificant. The t-statistic there is negative 0.57. That's going to be well below any critical value that we might find. We have lots and lots of observations. So can we come up with a reason now why age maybe theory doesn't justify including age in the model? And I think we can. In this case, age is correlated with experience. So when we're not controlling, when we're not holding experience equal, age ends up being a statistically significant predictor of wage. But really, age is a statistically, in that first regression, age was a statistically significant predictor of wage because of the omitted variable experience. The real reason why your wage might grow is because you have experience on the job. Each year you get a cost of living adjustment, you get small raises, and so experience might lead to higher wages, and that just happens to be correlated with age, but all else equal, the age you are doesn't really matter for what wage you should be earning. What matters is your experience, your quality as a worker, and things like that. So after we run this regression and we get a statistically insignificant impact on age, and we kind of ask ourselves again, it does kind of make sense that maybe age isn't actually relevant to the model at hand. What matters is your experience, what matters is your education. Age can be a proxy for those things, but once we're holding those equal, it sort of makes sense that age isn't really a relevant factor. So now that we've given ourselves at least somewhat of a theoretical reason that age maybe shouldn't be a relevant variable, we're going to go to the other three criteria to see if we can decisively rule it out of our model. So when we include age, it's statistically insignificant. So that rules out our second criteria of the t-test. Now we're going to rerun this model without age in it. We'll note the adjusted R squared from the model with age is 0.1305. And the adjusted R squared without age is 0.1312. Adjusted R squared actually went up by 0.007 when we took age out of the model. In other words, our model got better, is predicting wages more efficiently without age in it. That's another strike against age in the model. This is pointing towards age potentially being an irrelevant variable. You might also notice that and this is ever so slight, but when we took age out of the model, originally experience had a t-statistic of 4.08, which is statistically significant. When we took age out, the t-statistic went up to 7.79, even more statistically significant. And more importantly, the confidence interval, with the higher t-statistic, the confidence interval is going to be much more precise. Because age and experience in this case are kind of highly correlated, when we included both of them in the model, the regression had a little bit of a hard time deciding what is really an impact due to experience, what's an impact due to age. We know, based on how the world works, that what drives your wage is your experience, not your age. So we're able to kind of help the regression out by taking age out of the model, and now it can attribute all of that benefit of getting older to people's experience. It kind of is loading on the correct variable now. So our first criteria was, does theory justify including age? And we came up with a reason why maybe no, it doesn't. Our second criteria is a t-test. When we include age, is it statistically significant? No, it's not. Our third criteria is the adjusted R squared. Does adjusted R squared go up or down when we exclude age? And it turns out adjusted R squared goes up, which also points to the fact that age is maybe an irrelevant variable. Our last criteria is bias. When we take age out of the model, do other coefficients change by very much? So when we look at the coefficient on education, 0.467 with and 0.467 without. So education does not change very much. Big city, 1.31 with, 1.31 out. Big city does not change very much. The impact of experience does change a little bit. It goes from 0.11 to 0.09. How can we tell if that's sort of a big enough or significant enough change? Well, let's consider the 95% confidence interval for experience. In the original model, our range of values for experience was 0.05 to 0.166. Is 0.09 inside that range? Yes, it absolutely is. So even when we take age out, yes, the coefficient on experience changes a little bit, but it doesn't move it outside of what our original confidence range was anyways, so we're not concerned that the omitted variables bias from excluding age is too high in this case. So this was just sort of a quick example of how of assessing whether or not a variable was irrelevant. In this case, we would come to the conclusion that age is an irrelevant variable. It doesn't pass any of our four tests of theory, the t-test, adjusted R squared, or bias in the other variables. All right, so that's it. Irrelevant variables, it's covered in the same chapter of the textbook as omitted variables bias. It is on par the sort of secondary concern. Like I said at the start of the lecture, if you're on the fence between including or excluding a variable, it is worse to have omitted variables bias because that causes all of your other coefficients to be kind of incorrect interpretation. It's worse to have omitted variables bias than to have an irrelevant variable. Ultimately, including an irrelevant variable makes all of decreases the precision or decreases the t-statistics in magnitude of the other coefficients in the model. That's less of a concern than having biased results, but it's still something to pay attention to. It's something I'm going to ask all of you to look for in your final projects. Each of you, after you run your initial model, is then going to sort of assess whether or not you have any irrelevant variables in the model. So getting a sense of what is and isn't an irrelevant variable is an important skill for an econometrician to have. Thanks for watching, guys. I'll see you in class sometime. Well, I guess I don't know when you're watching it, but probably sometime later this week. Bye.